Replenishing the Earth. Rehabilitating Degraded Land for Agricultural Purposes. Title: Replenishing the Earth. Rehabilitating Degraded Land for Agricultural Purposes. Introduction. 150 words. The Earth faces a significant challenge in meeting the growing demand for food due to population growth, climate change, and environmental degradation. One crucial aspect of ensuring future food security is rehabilitating degraded land for agricultural purposes. Degraded land refers to areas that have lost their productive capacity due to human activities, climate change, or natural disasters, among other factors. By rejuvenating these ecosystems, we can mitigate the adverse effects of land degradation while contributing to global food production. Section 1. Understanding land degradation. 300 words. Land degradation is a complex issue that affects agricultural productivity, economic growth, and biodiversity. It is estimated that around 25% of the Earth's land area is degraded to some extent. Factors such as deforestation, overgrazing, improper land management practices, soil erosion, and pollution contribute to the degradation of land. As a result, the productive capacity of these areas decreases, leading to declining crop yields and increased vulnerability to droughts and floods. Section 2. Importance of rehabilitating degraded land. 300 words. Rehabilitating degraded land is crucial for several reasons. Firstly, it helps to increase agricultural productivity by providing additional arable land for cultivation. Secondly, it contributes to biodiversity conservation by restoring habitats and promoting the growth of native plant and animal species. Section 3. Approaches to rehabilitating degraded land. 500 words. There are several approaches and techniques that can be employed to rehabilitate degraded land for agricultural purposes. These include 1. Reforestation and afforestation. Planting trees and restoring forests can help improve soil quality, prevent erosion, and regulate water availability. Moreover, forests act as carbon sinks, reducing the concentration of greenhouse gases in the atmosphere. 2. Conservation agriculture. This approach involves minimizing soil disturbance, promoting crop rotation, and maintaining permanent soil cover. Conservation agriculture enhances soil organic matter, reduces erosion, and improves water retention capacity. 3. Agroforestry. Combining trees with agricultural crops provides several benefits, such as enhancing soil fertility, diversifying farm income, and protecting crops from extreme weather events. Agroforestry systems can be tailored to specific ecological and socio-economic conditions. 5. Integrated pest management. Adopting integrated pest management practices reduces the reliance on chemical pesticides and promotes the use of biological control methods. This approach protects both crop productivity and ecosystem health. Section 4. Success stories and case studies. 300 words. Numerous success stories demonstrate the potential for rehabilitating degraded land for agricultural purposes. For example, in Niger, the farmer-managed natural regeneration technique has successfully restored degraded land, resulting in increased agricultural productivity and household incomes. Similarly, in China, the Grain for Green program has led to the restoration of vast areas of degraded land, reducing soil erosion and improving water quality. Section 5. Challenges and the way forward. 250 words. Rehabilitating degraded land is not without challenges. Lack of financial resources, limited technical expertise, and conflicting land use policies often hinder restoration efforts. Additionally, social and cultural factors may also pose obstacles to the adoption of sustainable land management practices. To overcome these challenges, it is crucial to establish supportive policies, provide financial incentives, and strengthen technical capacity at local and national levels. Collaborative efforts among governments, farmers, scientists, and civil society organizations are necessary to scale up the rehabilitation of degraded land for agricultural purposes. Section 6. Economic benefits of rehabilitating degraded land. 300 words. In addition to the environmental benefits, rehabilitating degraded land also offers significant economic advantages. By restoring fertility and productivity to these areas, agricultural yields can be increased, leading to higher incomes for farmers and improved food security for local communities. This, in turn, can contribute to poverty reduction and economic growth. Rehabilitated land can also provide opportunities for diversification and innovation in agriculture. Farmers can explore new crops or farming techniques that are better suited to the restored ecosystems. This diversification can help mitigate risks and increase resilience to climate change and market fluctuations. Furthermore, rehabilitating degraded land can create employment opportunities in rural areas. The restoration process itself requires labor-intensive activities such as tree planting, soil preparation, and land management. As a result, local communities can benefit from increased job opportunities and improved livelihoods. In addition, restored ecosystems have the potential to generate revenue through ecosystem services. These services include carbon sequestration, water filtration, and habitat provision for pollinators and wildlife. By valuing and monetizing these ecosystem services, land restoration projects can generate additional income streams for farmers and communities. Section 7. Scaling up land rehabilitation efforts, 300 words. To address the global challenge of land degradation, it is necessary to scale up land rehabilitation efforts. This can be achieved through a combination of policy interventions, financial support, and capacity-building initiatives. Governments play a crucial role in creating an enabling environment for land restoration. They can develop and implement supportive policies that incentivize and facilitate the rehabilitation of degraded land. These policies may include financial incentives, tax breaks, and regulations that promote sustainable land management practices. Governments can also support research and development efforts to improve the effectiveness and efficiency of land restoration techniques. Financial resources are essential for scaling up land rehabilitation projects. International organizations, development banks, and donor countries can provide funding for large-scale restoration initiatives. Additionally, innovative financing mechanisms, such as payments for ecosystem services or carbon credits, can attract private sector investment in land restoration. Capacity building is also vital to ensure the successful implementation of land restoration projects. This involves providing training and technical support to farmers, extension workers, and policymakers. It also entails promoting knowledge sharing and collaboration among stakeholders to learn from best practices and experiences. Section 8. Leveraging technology for land rehabilitation, 300 words. Advancements in technology are playing an increasingly important role in land rehabilitation efforts. Various tools and techniques are being developed and utilized to enhance the effectiveness and efficiency of restoration projects. One of the key areas where technology is making a significant impact is in monitoring and assessment. Remote sensing technologies, such as satellite imagery and drones, provide valuable data on land cover, vegetation growth, and soil conditions. This information can help identify areas that are degraded and assess the progress of restoration activities. It enables stakeholders to make informed decisions and adjust their approaches accordingly. Another area where technology is being leveraged is in the implementation of restoration techniques. For example, precision agriculture techniques are being used to optimize the use of inputs, such as water and fertilizers, and ensure their targeted application. This not only increases efficiency, but also reduces costs and minimizes the environmental impact. Furthermore, innovative technologies are being developed to enhance soil health and fertility. For instance, biochar, a type of charcoal produced from organic waste, is being used as a soil amendment to improve nutrient retention and water holding capacity. Similarly, mycorrhizal fungi are being employed to establish symbiotic relationships with plants, enhancing their ability to access nutrients from the soil. Technology is also being utilized to promote knowledge sharing and capacity building. Online platforms and mobile applications provide access to information, best practices, and training materials. These tools facilitate collaboration and learning among different stakeholders, allowing them to exchange experiences and foster innovation. Section 9. Policy and governance for land rehabilitation, 300 words. Effective policy and governance mechanisms are vital for the success of land rehabilitation initiatives. The formulation and implementation of supportive policies can create an enabling environment that incentivizes and promotes land restoration. Governments play a crucial role in setting the direction and creating the legal framework for land rehabilitation. They can implement laws and regulations that promote sustainable land management practices and prioritize the restoration of degraded areas. Additionally, governments can establish clear land tenure rights to ensure that farmers have secure access to the restored land. Participatory approaches in governance are also essential for the success of land rehabilitation projects. Involving local communities, farmers,